Yes.
Yes.
Looks great.
Hello, everyone. My name is Douglas, and I will present the South Atlantic Ocean Database project. Next, please, Marcela. I am Douglas. I'm a oceanographer from Brazil, and this is the group that developed this project. Tobias was our mentor, and Marcela Strane, me, Luiza Stein, Danilo, Denise, and Paula did this project. And the main problem that you have to this project is that the South Atlantic is one of the least observed oceans globally. For Brazilian waters, where we are, the almost all people except for Marcela, public data from weather buoys, TGs, EDCPs, and water equipment like gliders are still hard. And those data, when these exist, is dispersed across different institutions, from universities, Navy, and others. And this in practice means that the data does not exist for the community, and it can make possible positive impacts to the society. Next, please, Marcelo. And here, our goal is to gather dispersed oceanographic data of the South Atlantic Ocean and make it easily available for the public. And you try to put this in a programmatically way using Python. Next, please. And the main relevance of this project is this is in the core six United Nations Ocean Decade Goal, that is we need to have an accessible ocean with open and equitable access to data, information, and technology. And in the same doing this, we we achieve we achieve the other three SDGs goals of the United Nations for this for the decade. That's the climate action, life below water, and life on land. Next, please. Our workflow: first, we gather weather buoy data, then we apply a quality control to this, and the third moment we host this data on a SQL database, connect this database to an API, and make it public to make the accessible of its data the easiest possible. Next, please. For this 4 days, 5 days project, we choose just one data set. That's the data set from the Brazilian National Buoy Program. That's the Penny Boy in Portuguese. This is a project managed by the Brazilian Navy, and I'm 40 for the Brazilian to the Global Ocean Observer System, the GOOS. And for this week, we select just the weather buoys that was operational. That's collecting data to make it easy to work in 5 days and to complete all the steps during this week. Next, please. And here is a map uh, showing all the buoys that the Penny Boy program had since 2 decades ago until now, and the X sign is the operational buoys now. And here is to show that now we are with three, now with four buoys in the database. One is not in the map, but we have different buoys to implement agents bank in the future, and almost in all the Brazilian coast. Next, please. Now we will talk about the quality control.
So in this slide, we have our quality control flags. The flags are based on CARTOID, which is the quality control of integrated ocean observing system. CARTOID is the quality assurance, quality control of real-time oceanographic data. In the table, we can see the flags values. Number 1 means that data is okay. 2 was not evaluated. 3 suspect. 4 fail. And 9 missing data. Next, please. We will show a case study that we apply the quality control. In this case, we show the result of gross range test, but we tried the other tests too. The buoy is located on Fernando de Noronha, that is an island in the northeast coast of Brazil. On the right, the first figure shows the wave height, and we can see that no data has failed, since we have only green circles. And in the figure on the bottom, we have the wave peak period, but now we can see some suspect and fail data in the yellow and red circles. And these figures were made with Olivis, so they were interactive, but here we just put the screenshot. Next, please.
So we've built our database using PostgreSQL and structured in 2 different tables, one for metadata and one for the data itself. And once we gather the data, we process it, we store that on our database, and then we host it on a Heroku server. And we do run Chrome work, so our database is updated every hour. And it's ready to be delivered and accessed by the final client using our API.
So our API was developed using Fast API, and after Douglas inputted all the data, we were able to test it and connect it to the API to ensure that it's working over here. And once the database was set up, we were able to connect those and use Docker to package all of the items in our container and deploy it onto Heroku as the cloud service that hosts it on the internet. So users are able to find their files as CSVs and then have them transformed into JSON data, as shown here. So the database will have many different types of data for the buoys, and you can actually get single data as well. And these are some of the outputs.
Hi, Marcela. Sorry, you're a bit over time. So if you could finish up quickly, that'd be great.
Yeah, so some of the challenges we faced ended up being maybe some time zone differences, using GitHub as a team, a coding experience across the members. And so some of our future goals were kind of implemented through this project by increasing access to data, being able to find the data and make it more accessible, and finding a good host for the data overall. So thank you. Any questions?
Thank you. That was really fantastic, and you guys got so much done.